In today's Technical Corner, Paul Ensor and I are going to be talking about something a little bit different. At ITC, Paul, you used to be known for solids. Now obviously you're known for indexable as well. This kind of sits in the middle somewhere.
Yeah, so this is sort of introducing the new Widia DuoLock system. DuoLock being the name for a system that uses two different types of location for an interchangeable head system. They've teamed up with Hamer with the bodies, etc., so you can get integrated bodies, shank bodies with the Hamer lock systems on. But the key feature is that people who make interchangeable head cutters have always used a single thread or lock for holding the actual head into the body. So it's used more for lighter applications.
Sure.
What Widia have then done is looked at these and improved it to the fact where they're using a twin system. They've got a thread for actually holding the insert into the body, but a twin ground position to give you accuracy and location.
Okay, is it a similar argument to face and taper tool holders where you've got dual location, so presumably faster feed rates, deeper depths of cut, more productivity?
Correct. It's the fact that you've got the two ground locations on the head gives you repeatability far in excess of what other manufacturers give you at the minute. So if you're in a high accuracy production environment, changing the heads over won't interfere with your offsets, etc. And because you've actually got those holding the insert true and the thread just locking it in, means that now you've got a head that with 1.5 times diameter cut length that can be fully utilised. Okay,
because some of these tools, maybe the ball nose and this finishing tool here, you're not necessarily going to take big depths of cut, but some of these, you know, a ripper cutter, 4-flute ripper, you know, to use that correctly, you've got to engage the tool.
And that's exactly what they're designed to do. Going from ripper forms, initially roughing out, you can actually use the same body and change straight onto a finishing head. The repeatability means that you can move from one to the other, so you can have a single shank in the machine and actually do all your operations off a single shank. All the heads are based around the Variamill program, which is the anti-harmonic flute geometry that Widia have. So it's designed for use in bigger depths of cut. Even doing trachoidal milling with these is feasible.
So why use this instead of solid carbide? Is it down to economy?
You'd be surprised that these heads, because of the quality of the grind, of the locations of the threads, the heads are actually quite expensive to produce. So it doesn't actually make them that much cheaper than using a solid end mill. But what it does give you in a high production environment is repeatability without having to keep setting up and doing your offsets on your machine. So to change heads and actually move on to the next operation or to keep an operation running, it's all about reducing the downtime.
So you've mentioned Variamill and you've mentioned a lot of people using this. I've got two questions really. One, who is using it? And B, is that the full range?
The first answer to your second question, the full range. There is a more extensive range. This is just a representation of some of the geometries available. But it will take you all the way from, you know, cast irons, stainless steels, into the aerospace materials, all the way through to aluminium grades. We've actually got a chamfer tool here, and there's also a corner rounding tool available, obviously based on high production repeatability as well. So the range is quite a bit bigger than you see here. Who's using them? It's a very new product, but we have introduced it into several companies now where they're predominantly doing production, high production, so the downtime and changing tools and not having to change offsets in the machine, etc., is paying dividends for them. They've also launched, with inside this range of heads, dedicated geometries going more into the aerospace materials as well. So we would expect that to be pushing into those fields as well.
And my final couple of questions, Paul. One is, how do we fit it into the back end? And secondly, how about sizes?
So I've just bought a representation here of 12mm diameter heads fitting into a standard shank back end here. As I said before, you can get the shanks in various lengths, various diameters. You can get integral shank versions as well. The heads themselves will go all the way up to 32mm diameter,
okay.
So very large tools. So you can see the sort of power that you can put through the DuoLock system. The heads actually locate initially just by screwing in by hand, but then depending on the head diameter there is a torque force. You can buy a torque adapter from the catalogue which just locks into any standard torque wrench, they will give you torque figures, and it is very important that you actually torque them up to those recommended pressures. Obviously, to lock them in, because the cutting forces, especially on the larger heads, can get quite large.
And obviously we've got these grooves in the bottom, but you don't need to use that system, no? No,
that is just a demonstration once again about how much power you can actually put through these heads, in the fact that the shanks come as standard with the Hamer lock system on them, to stop them pulling out of the true holders. So anything where you've got cutting forces that will actually be able to pull these things out of a holder, you know, where they're putting a retaining system on, such as the Hamer system, it's worth looking at.
Okay, and just finally, what's this product called and how can they learn more?
It's Widia DuoLock, Duo obviously being a twin lock system. It's available through the Advances 2018 catalogue from Widia. This is available online on our website. You can download it as a PDF or contact us and we'll send it to you, or speak to one of our engineers.
Many thanks, Paul.
No problem.